Hello everyone. Today we are going to continue with the application of derivative, and in this we are going to discuss about the monotony, maxima, minima, and increasing and decreasing function. As you can see from the graph starting point on the x-axis is A and the end point is B. So domain of the graph is in the interval AB. The points x is equal to A and x is equal to b are called endpoints. If you can analyze the graph, the point C1, this point C1, point C3, and B, these are called as local maxima. We have local maxima at point x is equal to C1, C3, and B. Now, we have the local minima at A, C2, and C4. So we have a local minima or just minimum point, and at x is equal to A, x is equal to C2, x is equal to C4. So if you can analyze the graph from A1 to C1, A1 to C1, the function is increasing. The function is increasing because it is goes up. From C1 to C2, the function is decreasing because it goes down. From C2 to C3, the function is increasing again, and C3 to C4, the function is decreasing. From C4 to C5, again the function is increasing. So a positive gradient means that the function is increasing, goes up. A negative gradient means that the function is decreasing, goes down. So as we already know that the derivative is equal to the gradient. So when derivative is greater than 0, then function is increasing. It goes up, slope goes up, and derivative is less than 0, then function is decreasing. it goes down. So the increasing or decreasing behavior of a function is also known as monotony. There is a point which is called turning point. If function has a turning point of maxima or minima, then there exists a point when the derivative is equal to 0. At the turning point, the derivative is equal to 0. So when the derivative is equal to 0, whatever the point we are getting, those points are called as stationary point and also called as critical point. We are going to discuss about the first derivative test. In the first derivative test, we will find out whether the function is a minimum or maximum. So you have to check the sign of function to verify if the function is increasing or decreasing just before and after C. Suppose this is the value of x and this is a critical point, and derivative of the function is f dash x. So just suppose just before the critical point, if you just insert the value inside the derivative, if it is comes out to be positive and after that it comes out to be negative, then it is going, the slope goes up and then the slope goes down. So this is called point of maxima. Point of maxima. Suppose you have a derivative. This is a critical point, and before the critical point, the derivative of function comes out to be negative, and after the critical point, the derivative of the function comes out to be positive. So when it is negative, the slope goes down. When it is positive, the slope goes down. So this is called point of minima. If the sign does not change, we have neither a maxima nor a minima. So we are going to learn about the methodology, how to find out the minimum or maximum value of the function. Suppose we have given a function y is equal to fx. The step one is find the derivative. Step two is solve for derivative equal to 0. Suppose the roots, after equating to 0, the roots are supposed to be a, b, c. Step 3, construct a table to perform the first derivative test. So I'm just constructing the table so that we come across how to apply the first derivative test. Suppose x is an input and f dash is a derivative of the function. We have three roots a, b, c. Suppose before a, the derivative is positive, and after a, just after a, the derivative is negative. So it is goes up and then goes down. So point A is a point of maxima. It is negative after A. Suppose the derivative is positive. It goes down and goes up because it is positive. So this is going to be point of minima. Suppose at C, before C, the derivative of the function is positive, and after C also the derivative of the function is positive again. So it goes up and again goes up. So it is nothing. There is no point of minima or maxima at point C. So this is the methodology, and based upon that, we are going to solve one example. Example 1. Suppose we have a function which is equal to 1 by 3 x cube minus 2x square plus 3x plus 5. So the first step that we need to follow up is we have to find out the derivative. So the 3 drops and 3 is being subtracted by 1. 2 drops, 2 is being subtracted by 1. The 3x derivative is 3 and the 5 derivative is 0. So this is equal to x square minus 4x plus 3. So x square minus 4x plus 3 equated to 0 to find out the stationary or critical point. So after solving this quadratic equation, the solutions are x is equal to 1 and x is equal to 3. After that, we construct the table. On the table, on this critical point, we will find out whether the point is maxima or minima. This is x and this is the derivative, which is equal to x square plus minus 4x plus 3. The critical points are 1 and 3. So you just insert any value which is less than 1. Suppose I just insert 0.8. If I insert the 0.8 into the derivative of the function, it comes out to be positive. If you insert any value greater than 1, 1.1, the derivative comes out to be negative. So slope goes up and then down. So this is the point of maxima. Beyond 3, suppose I insert 3.1 into the function. It comes out to be positive. So slope goes down and up. So this is the point of minima. So we can conclude that we have maxima at x is equal to a, and we have minima at x is equal to 3. The maximum value of the function at x is equal to 1 is equal to 6.33. You just have to insert the value of x is equal to 1 into this function. And the minimum value of function f3 is equal to 5. Again, you have to insert the value of x is equal to 3 to get the minimum value of the function. So this is about the first derivative test to find out the minimum or maximum value. In the next class, we are going to discuss about the second derivative test. So thank you very much and have a nice day.